So you've been looking at integration and how to use integration to find area, you know, maybe under a function or over a function, maybe blocked off with the x-axis or the y-axis, whatever way you want to describe it. And the last thing that you can kind of be asked is not just the area under the function, but you could be asked the average area, you know, on average per unit. How much area is there? Now, I'm going to just say that there's a formula for this. At the start of this video is explaining where that formula comes out of. If you've no interest in knowing where the formula comes out of, even though I think it's helpful to understand it because the formula isn't in the log tables, and if you understand where it comes out of, I think it'll pop back into your head very fast and you won't maybe have to learn it off because you actually understand. So, start of the video, I'm going to explain it, where it comes out of, the idea of it, and then, you know, if you want to skip that part, that's fine, and you can look at the next part of the video that shows how to use the formula. So if we look at this function here, I'm going to pick a really easy one. I've drawn the function f of x equals x. Now that's also y equals x, just in case. You know, instead of f of x, you can replace it with a y. So what I'm going to ask you is, what if I asked you for the area under the curve bounded by the x-axis between 1 to 5. Okay, well actually no, because it's a perfect triangle, let's just actually go from 0 to 5. So can you see the triangle that I'm asking you about? This will be the easiest way to probably explain it. So there's my triangle that I'm asking you to find the area of. Now, half the base, so 1 unit, 2 units, 3 units, 4 units, 5 units, multiplied by the perpendicular height, 1 unit, 2 units, 3 units, 4 units, 5 units, would give me the area of the full triangle. Okay? Which means that the area here is 25 over 2, which is 12.5 square units, or units squared. That's what you have been looking at. But the way you've been doing it is, oh, I'll integrate the curve from 0 to 5. And that'll also get me the same answer. So because it just happened to be a perfect triangle, I just wanted to show you could have gone half base by perpendicular height. The way you've been looking at it is, you know, if you have the curve and you integrate it, you get the formula for the area under the curve, or, you know, in this situation, we're going with the x-axis, so the area bounded by the curve and the x-axis from 0 up to 5. So if I integrate that, you add 1 to the power, divide by my new power. From 0 up to 5, which means you throw in the 5. Minus when you throw in the 0. And you end up 12.5, again, units squared. So this is what you have been doing. They might now ask you for the average area. So like, if we look here, it's about half a square unit. If we look here, you know, we have about 1.5 square units. If we look here, we have 2.5. If we look here, you know, we have 3.5. Hope you can see this now. If you look here, you have like 1, 2, 3, 4 full units and a half a unit. And now what's the average So this one is a half own and this one has, 1, 2, 3, 4.5. So this one has 1.5, this one has whatever. What does it average out to be? So to get the average, we're just going to divide by, how many is there? Which is 5. So that's 12.5 divided by 5. Just show it the calculator. And I end up with 2.5. So on average, each block has about 2.5 square units. Some are a bit over that, some are a bit under that, but on average, that's how much there is. So this is the average area. So again, it's units squared or square units. Okay. The formula that you see looks like this. So this is actually the formula that you use for the average value, or in this situation, we're talking about the average area. It's the average value formula. So if they ever ask you, in a differentiation or integration question, what's the average? Well, you can use this formula to find it. And where does this formula come out of? Well, looking at what we just did, we had to find the area first. So it doesn't matter how you do it, but what you normally have been doing is recently you've been using integration to do it. Okay. And that's what's happening here. That's your integration part. So if we just ignore this for a second, this formula here gets you the area, let's say, under the curve, we're doing with the x-axis in this situation, from somewhere to somewhere. So that was the first step. We had to find the area. And then we divided by, it was 5 units. How did I do that? Well, I counted, but you could just go 5 minus 0. The highest number minus the lowest number. Or, earlier on I was saying, let's just do from 1 to 5. Well, then you'd have been dividing by 4. So 1, 2, 3, 4. Or you could have just said, we're going from 1 to 5. So that's 5 minus 1, that's 4. And that's what we're doing here. So for me to divide by 5 is the same as to multiply by 1 over 5. And that's all this part is. So this is getting the area. And this is where you divide by, or, here I multiplied by 1 over 5. I multiplied by a fifth, or that's the same as dividing by 5. Here, the way they write it, I'm multiplying by 1 over, again, it was 5 because it was 5 minus 0. So this is to get the average.